Hello everyone. I hope you all are doing great. Welcome to day 8 of Kubernetes project. In this project, we are going to learn how the blue-green deployment works, how rolling upgrade works, and we'll take a Java application. We'll first deploy the blue applications, then we'll deploy the green applications, and then I'll show you how we can switch between blue and green deployments. And then once blue-green deployment is done, I'll be moving to rolling upgrade concepts. So let us begin. First thing comes to our mind is what is blue and what is green deployment. So blue-green deployment is a release management strategy used to minimize downtime and reduce risks during software developments. It involves maintaining two identical environments. So what exactly happens? At a time, you will be having two identical environments. Blue will be your current production environment and green will be the new version of environment. And then in the live blue environment, all our applications will be running. All users will be connecting to the blue environment. You create a new environment that is green environments in a staging, of course. New version of application will be deployed and tested in the green environment without affecting the users. And then switching of traffic will happen between the blue and green. Once testing is done, traffic is redirected from blue environment to the green environment. Now, you can even monitor and roll back if needed. So if issue arise in the new environment, that is green environment, so traffic is switched back to blue to ensure minimal downtime. And you can decommission blue or keep it as a backup. So once if everything looks good in the green environment, you can decommission your blue environment, or you can keep it even if it's needed. Once our green environment is stable, blue can be removed as I told. So what is the benefit of this blue-green deployment? Zero downtime, user experience no service impact during the deployment. So during the deployment time, there will be no downtime. Rollback will be fast because if issue occurs, switching back to the blue environment is quick, and you can do safe testing in the green environments. Like in the new version, the testing can be done very efficiently and fastly. Now, so we understood blue-green environment, but there are some challenges. The biggest challenge is maintaining two environments required more money, more resources. So it's a bit expensive. And apart from that, the data synchronization. Suppose if your database is shared, data consistency must be managed carefully because your green environment, when you will be testing, you cannot um, sync data properly. You need to take care of data syncing. You have to be very cautious because there are two separate environments. Let us go deep dive into the project and implement the same thing in our infrastructures. So let us go to day 8 of our project. Here, first I'll tell you, this is a Java application. I'll be putting this code in GitHub repository. You can just go there, clone the code and start implementing it. Even if you don't know Java, that is fine. We don't need to go in deeper of Java. But to deploy these applications, I'll show you how to do the changes and basics I will explain. So we have a source main folder. Inside that Java, we have one UI controller and one demo application Java. Here in the UI controller, here we are using HTML. Directly here in the return, if you say somebody is hitting at the root path, we are telling h1 style color is green. So let us make it blue. First we'll do the blue deployment. Background color, and that's it. Just save this. This is the UI controller.java, and in the demo applications, and these are the contents. You don't need to go into the deeper, and I also don't go in deeper of Java ever. Now there will be one pom.xml file. Project related information is stored in this pom.xml file. Now, since this Java application needs to be deployed, Maven is one of the way you do your deployment. So using Maven, you do, and it's very easy to do the testings and do other things using Maven. So we have created a Docker file. In the Docker file, I'm using Maven. This is the image. And then work directory we are deciding is /app. We are copying our project object model, this pom.xml file. into the current place in the current app directory, and then copying all the source folder here, this source folder, to dot slash source inside the image. Then we are doing Maven clean package and skip the testing. So this will help to build the applications. And then we are using the Java image of 17. Our work directory is applications. We are copying this Maven. So copying from build. And here you see this is as build. So copying from build app target star.jar to application.jar, because to deploy the Java applications, we need the jar file. Now we are exposing this application on port 8080, and your entry point means your application will start using java-jar, and then your app.jar file will be given to you. So now you see how our Docker image is written, and it's quite clear that you are using the Maven image and then naming it as a build, and then pom.xml file you are copying all the source folders inside the image, and then running the Maven clean package, skipping the test cases, and then on the base of Java image you are copying this Maven to app.jar, and then you are exposing this application on 8080, and then you are running as an entry point, your Java application will run java-jar app.jar file. Now, our first requirement is to deploy the blue. So to deploy the blue applications, this is our deployment file. Let us see. API version app/v1, and this is quite clear. Metadata, this is Java UI app blue. The name you can give anything. Labels, Java UI app is the label, and version here, this level you have to remember, version is blue. We are making two replica, version is again blue, and in the templates version is blue, and here image name. So image name, let us tag it using the blue keyword. So Java underscore app colon blue, save this file, and then first we'll deploy the blue, then we'll go to green, and then we'll go here. And in the source code here, just make the background color right now is blue. Here you can see this is blue. So the background color should be shown to us in the blue. Now we have made the changes. We have to build the image, right? So I'll go to our system. I am in the day 8 project already. So clear the screen, do ls-ltr, go to Java UI app, because here our Java application code is placed. Do ls-ltr. Here you can see your Docker file is there. Just do docker build -t. Your image name should be Java underscore app colon blue and dot. So what this is do? This will build your image. So Docker image will be built, and its name will be Java app called dot blue. So tag is blue, and application, and this image name is Java app. So once this is done, we'll have the image ready. So let us see how much time it takes. So now it's building our applications. It is copying all the source code of Java. And once this is done, then we will have image. This image needs to be loaded to your kind cluster, as I am explaining in our previous projects. In the kind cluster, because since these images are stored in the local system, right now we are not using any private or public artifactory or repositories. So this image we have to load to our kind cluster. How you will be loading? That I have shown you in previous video. Here also I'll show you how to do the loading of these images, blue image, into your kind cluster, and once it's loaded, we'll move ahead with the further steps. Okay, so it's taking a little bit of time to build, but I hope now it should be finished quickly. Once this image is built completely, we have the option to load this image. And how we'll be loading the image? I have shown you in the day one steps as well. What we exactly do? We just use kind load Docker image, your Docker image name, and then the name of your kind cluster. In our case, it is DEVOPS-TECHSTACK cluster. So kind load Docker image, and in our case, it will be Java underscore app colon blue, and then this will help us to load there. So let us prepare this command here. So image build is done. If you do Docker images, you will be seeing, yeah, Java app with the blue tag here you can see. Now clear the screen, go to the top, and just remember it. Just copy the load command. So copy, paste the load command and change the image name. So in our case, the image name is Java underscore app colon blue. This is image name. This needs to be loaded to our kind cluster. And once this is loaded in the kind cluster, we are good to start using inside our deployments. So if you go here now, close this day one, go here. And if you see deployment blue, here already I have changed to blue. And you see container port is 8080, so it will be running on 8080. Here we are using two copy or two replica, and selector is application name is Java UI app, and the version is blue. And here also label also we are attaching the label as blue. So once this is done, you need to create a service. So for creating a service, if you see, API version is V1, kind is service, Java UI app service, Java UI app version is green here. Let us change it to blue because first we want to deploy the blue applications. And type is load balancer. It doesn't matter. Right now we are using not using load balancer. So we can set it to node port, or we can use the same local port right now in our system. So now our image is loaded. Let us do one thing. Go back. Here our deployment files will be there. So if you do vi of this deployment blue, everything should be okay. Just re-verify it. Our image name is already correct. So there should not be any issue. Just do now. So let us do KC. KC is kubectl. Alias name I have set to KC hyphen F, and then deployment, and our image, um, our file name is blue.yml. So just I am deploying. So deployment is done. If you see KC get pods, you will see pods are. So now if you see our two pods 5 seconds ago is running in our system, and it looks okay. So now clear the screen. You need to create the service. So for creating the service, first check service.yml file, and you see it is pointing to it is using the selector. Selector is blue. And what selector is doing? It matches with the version blue, and then it creates service for them. So now KC apply hyphen F service.yml. So our service will be created. So now you see if service is configured. Now clear the screen and just see KC get SVC to check if service is there or not. So if you see Java UI app service is already there. Now our service is there. What you have to do? You have to expose your application on port 8080. So KC expose. So for exposing our applications, let us see. Okay, so I don't have the command here expose. Let us go here in J1 and see if we have the expose command. So now what we can do? Port forwarding you have to do, right? So kubectl port forward like this way. Copy it and get your service name again. So KC get service, and then this port forward, and then our service name. So SVC slash, what is our service name? Java UI app service. So just do this. Okay, just do port forwarding this, and then you have to give the port details. So 8080 colon 80, and you can see now it is forwarding on port 8080. Let us go to our browser and open localhost 8080, and you can see your blue application is fine. So welcome to the Java UI. This name was wrong, but you can see with the color it was the blue applications already we have deployed. Here we missed to change the name to blue. But yeah, this is the blue color. You can see the blue application has been deployed successfully. We don't have any problem with the blue application now. Now, what we have to do? We want to just stop exposing right now or port forwarding. Now go here, and your blue application is running, but you want to run your green applications. So now let us go here on this, and then you see your green application. The version only label is green, rest all is okay, and here app name is Java underscore app colon green. So go here and go to your code. Here we can just deploy. We are taking the same code, but yeah, in companies, of course, the code will be different and you have to create a new image. So this, and here instead of last time we missed to change it, but this time it should be green only. So here it is a green. Now save this. What you have to do? Now you have to go to Java applications here again, and then you have to build the new Docker image. So how to do? Docker build -t Java app instead of blue. Now we are going to deploy the green version. So let us deploy the green version of applications. And this is again creating the image. So image creation is done very quickly. Now let us go here. I hope we have saved it before building the image. You have to load it, right? So if you go to load, then here you are going to load the green. So Java app green and your cluster name. So now let us load it. Okay, so it's telling it is already found on all the nodes. I hope the image is the correct version. So now, once this is done, what's our next step? Next step is to deploy our green applications. So if you do kc apply -f and then deploy your green applications. So green application I'm deploying. You can see it has been created, and if you see kc get pods, you will see the green pods also here. Once green pods are running, so if you see Java app green pod 7 seconds ago, it is running. So now you have both blue and green running, but your service is still pointing to the blue applications. How I can say this? So if you go to the service file and if you see here, it is pointing to the blue. What you have to do? You just need to shift it to point to green. And if you shift it to point to green, you have to apply this service also. So kc apply -f service -ymap. It will reconfigure the service because you are changing the level matching for your service. So once this service is reconfigured, your application will point to the green one. Once it's pointing to the green one, you can verify all the functionality of your code, and after that you are good to proceed further and decide switching your applications. Of course, this deployment you are not going to do directly in production. First, you will do it in lower critical environments. And once everything looks good, then only we are going to deploy it into the real production systems. So, of course, in every organizations, we have two environments parallelly run. One will be production and one will be non-production. Or even some companies have multiple levels of environments. Like for the dev members, there will be a development environment. For the QA members, there will be a QA environment. So now you see your service is configured. Now what you have to do, do the port forwarding. So port forward, and your service name is same. So let us do the port forwarding now, and it's forwarding here. Now go here and refresh this page, and let us see what happens this time, because as per our expectations we should see the green, and here you can see your green application is live. So I assume this is your expectation. So you verify your web application is working fine, there is not any problem, then you can decide and go and evaluate your blue applications. If you see some problem or you are getting some issues, still you can go and use rollback it and go and use the blue applications, because right now your both blue and green applications are running. You can decide and you can delete it. So one more concept which I wanted to explain before finishing this project. So if you go here, you have used a concept called pod selector in your service. You have used some label. So what is exactly pod selector? A pod selector is a Kubernetes service is used to define which pod the service should route traffic to. So it is a key part of how services work, ensuring that service is directed only to the intended group of pod. And how the pod selector works: a service in Kubernetes route traffic to a set of pod based on the level, and we have attached the blue and green level there. So selector field in the service specification matches the level of target pods, and only pods with the matching level will receive traffic from the service. And this way you can use the concepts of pod selector and you can redirect your traffic by changing the services accordingly. I hope this project was really useful for you, and almost similar kind of setups organization uses. But in the next video, I'll be showing you how the rolling upgrade works.